Power factor correction systems are designed to enable efficient use of power through decreasing the idle current flowing through the grids. Today we'll look at the main power factor correction formulas. The part of the input power that is converted into the output power is called the active power. It is normally indicated with the letter P, measured in watts and calculated in accordance with the following formula. P equals product of voltage and current multiplied by cosine phi multiplied by square root of 3. Like I said, active power is measured in watts. In an ideal case, all the input power should be converted into active output power, say into actual output power of the electromotor. In reality, the quality of such conversion depends on the phase displacement between the current and the voltage. It is indicated as cosinus phi and called a power factor. Electric machines, like electric motors and transformers, operate by converting electromagnetic power. Part of the input power is used to create and maintain the magnetic field. The inductive load causes a positive phase displacement between the voltage and the flowing current. The power generated by portions of voltage and current that have a positive sign are called reactive power. This part of the full power is normally indicated as Q and measured in reactive volt-amperes or VARs. This power cannot be converted into the active power, and when the magnetic field changes, it goes back in the power supply circuit. However, when the magnetic field changes again, the same amount of energy is again consumed from the power supply circuit Q, product of voltage and current multiplied by the sinus phi multiplied by the square root of 3. The operation principle of electric equipment based on converting power into other energy forms. Electric power consumed by equipment from the power supply source is called total power, indicated as S, and measured in volt-amperes. It consists of active and reactive powers. S equals product of voltage and current multiplied by square root of 3. The power factor, or K, of the power circuit is defined as a cosinus of the phase displacement between the first voltage harmonics and the flowing current of cosinus phi. Another definition for a power factor is a ratio of the active power to total power, power factor cosinus phi equals P divided by S. The reverse magnetic energy returned to the supply grid in circuits without compensation can be temporarily stored in capacitors and then used for further alternation of the magnetic field. To select the right capacitor, the required reactive power, Qc, can be calculated using the following formula. Qc equals total power multiplied by the difference of tangents of angles Φ1 and Φ2. Usually the power ratio is not fully compensated to reach the value cosinus phi equals 1, since this could lead to overcompensation when the load is changed. Normally, power companies set the allowable value cosinus phi, to which the initial power factor cosinus Φ1 need to be compensated.